Now let's talk about performance in general a little bit. Like I said, .NET 7 surprise is faster than .NET 6. Would be sad if it was the opposite, right? Like, oh, it's our slowest .NET release ever. Wouldn't go over so well. So in a way, it's what you expect it to be. 7 is faster than 6, 6 is faster than 5, and so on and so on and so on. But what's interesting is that this time around, this is really a fairly major thing. So a lot of the things that are there, whether it's core CLR performance, JIT compile performance, all the way through to the other end of the extreme, which is things like entity framework, a big focus was on making it faster, making it scale better, and so on. Okay. Now, a lot of these things are not stuff that you have to do as a developer. It's just there and you benefit from it. So things will just run faster. And one of the areas that I wanted to pick out there is the way .NET compiles. And as we know, .NET is not raw compiled. It compiles into IL code. So the C# we gets compiled into IL. The IL then gets loaded into memory, gets JIT compiled, just-in-time compiled into the raw code that then executes. And that's great because JIT compilation has many, many benefits. It's more generic code. It's code that can be optimized for the platform that it happens to be running on. So the same piece of code on a high-powered server in Windows may compile different from the same code running on an iOS device to take advantage of the individual things that happen on these different scenarios. So it's great, but it also has downside, and the downside is usually throughput during startup. Because this JIT compilation has to happen during startup, it takes a little longer to start. So we can do things like native compilation, that's been there, but then of course we lose some features and we lose the flexibility. So ever since .NET Core, and especially .NET Core 3.1, the Microsoft team has spent a lot of time making things better in the JIT department. And one of the things that was introduced there is tiered compilation, which is where things start up fast with not so much optimization and then get optimized over time. And there's a concept called on-stack replacement that's been introduced since the 3.x timeframe, which means code that gets compiled, individual methods and so on, are compiled quickly and then replaced over time. But that only used to work in certain scenarios. Like it didn't used to work when there was loops inside the code. And of course, we have a lot of code that does for loops and other for each and all that sort of stuff. And so this has been greatly improved in .NET 7. Now I want to do a demo about that. It's very difficult to demo performance when you are on an online streaming presentation. So what I have done is I have created a recording of a demo just before I started this. And it has two great benefits. First of all, we are not being slowed down by me streaming this to you. And secondly, I've in this demo, I have some stuff where I'm doing benchmarking over time. It runs a few minutes and you don't have to sit here and watch me do it. So let me roll the recording that I've created ahead of time here.
For my first performance-related demo, what we're going to do is we'll simply create a new project that's a very simple console application. We will pick .NET 7 as the target we want to build. And then we're going to simply do a very straightforward loop as our sample application. So all we're doing here is we have an integer variable, we count it up, and we let it run forever. If it runs in the loop the first time, we'll create a little output. Now this output will start repeating because eventually the integer will overrun and it'll start over from scratch. And so we'll build this in release version because we want it to be optimized. And to get a little more information out of this, we will also set an environment variable. So what we'll do is we'll come in here, we'll set this particular variable to 1, which will give us a little more information on the output. And then we'll simply go ahead and we run this. We let it run here in our console window, and we're going to see some very interesting things here. The first thing that's going to happen is because we've set this environment variable, we see some additional information about the JIT compiler and how it compiles the code that is running. And so what we did is we created just a top level simple console application. So what the JIT compiler does is it inserts a main method for us that it can run, doesn't have a name, and it just goes ahead and runs it. And so we see it created it here, had a certain size, had a certain NIL, it also had a certain code size, and that was just unoptimized the first time it ran. But then because it now does this on-stack replacement, OSR, as this runs in a loop, it is now smart enough to apply OSR in a loop as well. And that's something that previously, even in .NET Core, wasn't done. And now you see eventually it came by and it optimized the code one more time. And this time, as you can see, the resulting size is highly optimized and it's much more efficient as the compiler takes a closer look at this. So pretty nice, simple enhancement that we have here. That is a first performance example. So this on-stack replacement in loops is making a big difference because things that loop can, of course, cause us a lot of problems over time. And I also want to do a second example here. We'll just do something relatively straightforward, but what we will do for this example, we will bring in a NuGet package to benchmark.net. Now, if you've never seen benchmark.net, that's a pretty cool little library that you can add that performs benchmark testing of your code, and it does so in a variety of ways and just makes it much easier to do benchmark testing. So I've included this here, just done as a NuGet package. Of course, you could have also gone into the UI and you could have said, let's add benchmark.net here directly. I've just done it in code. So that's run and that's been added. And so what are we doing in here? Well, we have a compute method, and this compute method has a result variable, and then we go through a loop that we run 1,000,000 times. And then in here we count up the result item by adding 1. And then there's an if statement in here that checks to see what the year is. And this year is a static read-only variable that's initialized to the current year. Now, as you can see, I'm doing this particular example in 2022, so this statement is going to be false, so this will never hit. But the point of this is we're introducing an if statement. So let's go ahead and let's run this. And that's going to, again, happen in the console window. And there's a few things we can do here, but we'll start running this. And maybe I should have turned off that environment variable again. But this will now run, and this will run for a little while. But now, by the magic of video editing, I've cut out a few minutes of wait time in it running the project and doing some testing, and we can see the results. And so we can see that our method here that we were trying to benchmark ran, and the mean time, the average time of it running, took 253.8 microseconds. So what would that have taken if we did the same thing in .NET 6? So let's go ahead and let's change this application to target .NET 6, and let's do the same exact thing again. And once again, I've taken out the boring parts for you and let this run for a little while. But now we see that the same method now ran almost 900 microseconds, so 3 to 4 times as long. And that's a very interesting result. That's just the difference between .NET 6 and .NET 7. And of course, .NET 6 was already highly optimized. So how can it be that something as simple as this code segment here can be optimized so much further? Well, the difference lies in the fact that the JIT compiler in .NET 7 is now smart enough to understand things such as this private static read-only variable is being initialized once. Now, of course, the year could change every time this runs, and this result therefore may or may not be true. However, it understands that once this has run, from that point forward, this is essentially a constant because it can never change anymore. And it then knew once this ran once that this was never going to be true because this expression can be treated as a constant once it runs. And therefore, this whole if statement can be eliminated. It never needs to be evaluated again, it can be completely removed from the generated output, and that's what it does. So it replaces the code that's on the stack and replaces it with a JIT optimized version that is lacking that line of or that block of code, and therefore it runs significantly faster. And that's one example of how efficient these little performance optimizations can be and how big a difference it can make to do those types of things.
So there you have it. Pretty cool stuff. These are two examples that I wanted to pick out from the performance details. Again, check out the code focus issues we have. There's a whole article just on that, and it has further links and stuff that you can look at, and I'm sure this will be a big thing in .NET Conf as well. But I thought this was pretty impressive, some of the things they're doing there. Now, while this ran, I did look at some of the questions that we had. Somebody online asks if Visual Studio is still going to be called VS 2022. That's my assumption at this point. I'm not 100% certain of this, but I think so. I guess we'll have to wait what they're going to announce next week or on the 8th. Now the question is WPF still supported? Yes, WPF is supported on the new platform, and there's easier ways to move to that as well. And then there's another question about .ms identity in .NET 7. Whether that's still a thing, basically, and honestly, I just do not know what the answer is to that. And finally, somebody internally at Code asking if GitHub will be any easier to use with all this AI stuff going on. And I'm not sure, Eric, that the answer specifically to your question is yes. Maybe that's coming, that AI will help us do conflict resolution and stuff like that, which would not at all surprise me, but there's nothing new that I am aware of as of this very moment.